Today we are testing and responding to a challenge that ozone test strips, such as these, are absolute proof that ozone is present. Now we're going to look at 8 different chemicals here that are in common use, and the first one here is probably the most is just water. The manufacturer of this strip tells us that water vapor will affect the reading. Here it's at 38-39% relative humidity, and we're just going to leave this in here for this fluke meter, and it is the 971 temperature and humidity meter, and we'll pull this out after it gets to its highest reading, and it's climbing nicely. And this is what you're going to get in a flood situation where the carpets are full of water, and you will have near 100% humidity. And we're climbing past 97, as you can see, and we're approaching 100. I think we're just fine. There we go. We're going to get our colorimetric test strips, and we're going to attach that inside, and all of these strips are registered at 10 minutes. So we're going to attach that up in here and let it react away. And there we go. The next strip that we're going to do here is a common adhesive. Each one of these little cups are going to have 1.5 ounces of product in it, and that's exactly right there. And we're going to adjust these strips so that they will be exactly where they need to be. And just before I turn it over, I don't know if you can see that discolor there. That will discolor with time. The next one here is common household ammonia, and this one has a little bit of a scent. And again, we're going to put in that 1.5 ounces and move on to the next one. This being a normal iodine solution, and again 1.5 ounces. And these are things that people would use every day in cleaning. Just fine there. On to acetone, a normal cleaning product, and this one here is something that would use in the beauty business. We're timing this experiment at 10 minutes. We'll tip these over and we'll have a look. This is a common agent that we use, hydrogen peroxide, and it's 91%. And we're going to use this here. There we go. Pine Sol, cleaning agent. I'll show you the label on that, something that you would expect to use on a daily basis in the cleaning business. That's ready to go. And our second to last rather, is isopropyl alcohol, 91%. And let's get our measured amount in there. The last chemical that we're going to use is a very large container of chlorine. Now, all of these strips are designed to react with time. We're going to see these colors are going to show up in various concentrations, and the darker, of course, would be the heaviest concentration allowable. And leave that. See if we get a reading just for what may be in the air. As the manufacturer stated, you may have a problem with, or an issue with humidity, and also with air movement. So we've got a fan here that you would tend to use, not as terrific an air movement as you would have for trying to dry carpets. But let's see if we get a reaction with just straight air movement with no chemicals present. So we're going to put that right down here and around the middle. Well, here we've arrived at the time limit at 10 minutes, and this was our first look. It was at the moisture here in the chamber. So we're more in this range here at 90 to 150, and that's micrograms per meter cubed. And on this, looks like we've got our lowest reading right in the creamy range there, partially in between. So again, about the same as the water. Ammonia. Put that in the light. Let's turn this around so we can get a good look at it. Kind of the mid-range there. So it's also showing as an oxidizer. It should be completely clear or white if there was no activity, which would be the top band up here, so we can clearly see that that's not the case. So if we were to believe that, we would believe that these first three products were ozone, including the water. Here's our iodine solution. Oh my goodness, so we've got quite a dark reaction here. Now we're going to have to travel down to the end and perhaps even beyond that. That's the highest reading we can get, is over 210. Let's move over to the acetone. Again here, and we turn that over. Here's our reading. It's a light reading, and it's very close to that. Certainly isn't white, so we've got a lower reading here. And the next one is hydrogen peroxide, and you can see that really is aggressive, as much as the acetone, if not more so. So it's in the highest reading that this strip will allow. Next one is the household cleaning solution, pine sol, and it's coming up as, let's get that straight here, not as white, but in the first to more second range here. The isopropyl alcohol at 91%. And let's look at our ranges here. So it's not that dark, probably just in there, so at 90 parts or below. This one for the chemicals would be the chlorine. It's a fairly aggressive reading, but not as dark as some of the other ones, probably in between these two. So at 210 would be a fair. That's what we're seeing right now. So just air movement will affect the strip. So not quite as dark as that, in the 90 to 150 range. And the last strip is just in the air without air movement. And it's not white, probably in the first range. Welcome to Ozone Test Part 2. Here, in this segment, we're going to show, or attempt to show, that a sophisticated ozone monitor can be fooled or tricked into thinking that ozone is present. This is an ozone monitor that's been used for 10 years by the FDA, Department of Health in Canada, and by the British Geological Survey in the Antarctic to show ozone levels at ground level. This is a common household chemical, and we're going to show that there is a reaction, and we're going to show you those real numbers. This is at parts per billion, but at 0.099 parts per million, and we'll see what happens here. I'm not going to touch the chemical, we're just going to get some of the vapors that are above it and see how quickly the reaction times accrue with this particular unit. And there we have it, it's right off the scale. So the parts per billion is just rising. So the averages are trying to catch up, but the real measurement is right here. So 15,000 parts per billion. At this point, we're going to move on to another chemical, and this is pure acetone. I don't think we've peaked. So again, is this an ozone product? Absolutely not. This is an ozone calibration meter, and we're going to see if we can also fool this meter into thinking that ozone is present. We've got chlorine here, and we're going to put that in front of the sniffer. We've taken it off the other device, and we have it where this meter can pick it up, and we should see a reaction here shortly. We're getting some exceptional readings here, and this device is thinking that it's ozone when in fact it is chlorine that you would use on a daily basis. And it's acting as if there was ozone present, but we know there isn't. So is it possible to trick or fool a sophisticated meter such as a Draeger? Yes, it is. And so we can see in all of these chemicals that all of them are not ozone. They're common use chemicals, and they're showing as if they're having a positive ozone response. So can we say that the ozone strip is definitive? Absolutely not.